Subtopic number 6, which is on Kirchhoff's rules. So in this subtopic, you should be able to state and describe Kirchhoff's rules, and most importantly, you have to be able to use Kirchhoff's rules. So in our syllabus, it is a maximum of 2 closed circuit loops, and basically use scientific calculator lah untuk solve the simultaneous equations. Okay, so there are 2 rules for Kirchhoff's. So the first rule is known as the junction or the current rule. So it states that the sum of the currents entering any junction must equal to the sum of the current leaving that junction. Okay, so mathematically it can be written as the one shown here. Okay, for example, let's look at point A. So this the current going in is I1 and I2 should be equal to the current going out, which is equal to I3, which is I3 lah. Okay, similar to point B here, junction B, the current going into the circuit, which is into the junction, which is I3, is equal to the current going out of the junction, which is I4 and I5. Okay, so that is on the junction ataupun current rule. Okay, so Kirchhoff's first rule ni untuk current lah, current saja. And then untuk Kirchhoff's second rule, it is the voltage rule ataupun loop or voltage rule. So it states that in any loop, the sum of EMF is equal to the sum of the product of current and resistance. Okay, so it is the summation of EMF equal to the sum of the product of current and resistance lah. Okay. Okay, so make sure you are able to memorize the sign convention. Okay, untuk EMF, if the direction of loop is similar to the direction of EMF, so EMF moves from negative to positive terminal. Okay, ingat ah, EMF from negative pergi positive terminal. If they are equal to the direction of the loop, then the EMF will be positive. Okay, kalau direction of loop is opposite to the EMF, now it is going to the left, and direction of loop is to the right, it will be negative. Kamu akan tulis negative di equation tu. Okay, product of IR pula sama juga. If the current is similar to the direction of the loop, it will be positive IR. Kalau direction of the current is opposite to the direction of the loop, it will be negative IR. Okay, ingat ah, sign convention ni very important. You should know this. Gitu ko nun. Okay, very important. You have to be able to determine whether it is negative or positive, right? Okay, so this is the problem solving strategy for Kirchhoff's laws. Okay, tapi it'll be easier when I'll explain in an example later lah. Okay, so first thing you have to do is you have to choose and label the current at each junction. Ini untuk Kirchhoff's first law. Okay, so you have to label the current at each junction, and then you have to take one junction, satu junction saja, and then apply the Kirchhoff's first law. Okay, Kirchhoff's first law is what? Total current going in is equal to total current going out. Alright, and then after that you have to choose any 2 closed loops. Okay, kamu pilih lah. Contohnya sekarang ni dia ada berapa loop? Dia ada, untuk example yang ini ya, untuk yang ini ada 1, 2, 3 loop. Okay, so there's 3 loops, and what you need to do is you have to designate a direction. Okay, you have to either put it as clockwise atau anti-clockwise. Okay, you choose either one je, clockwise ataupun anti-clockwise, and then you have to apply Kirchhoff's second law. Okay, so Kirchhoff's second law, it's what? Summation of EMF equal to the summation of the product of current and resistance. Okay, so that is on Kirchhoff's second law. So after that, you will obtain an equation from here and then from here. Okay, so you can then solve the simultaneous equation to determine the unknown currents and unknown variables. Okay, okay, now let's consider the circuit here. So now there is 1, 2, and 3 closed loop. Okay, so you can put either clockwise ataupun anti-clockwise. Oh sorry, we have to ikutkan steps there. Firstly, we have to choose a junction. Okay, so we have to choose a junction, and then contohnya we choose junction A, so we have to use Kirchhoff's first rule atau yang current going in, which is I2 equal to I1 and I3. Okay, so we have equation 1. Okay, and then we choose two loops, and then we determine whether and then we designate whether it is clockwise ataupun anti-clockwise. Okay, and then for this one, for loop 1, based on this, untuk example nila, dia pilih anti-clockwise. Okay, so they choose anti-clockwise. So from here baru kita boleh apply Kirchhoff's second law. Okay, so E1 plus E2. Kenapa E1 plus E2? Kita tengok sekarang. So the direction of the loop, beginilah, Miss tulis dulu. So this one, the EMF is from negative to positive. Okay, so this is similar to the direction of the loop, so they are positive. Okay, and then yang ini ada pula dia lukis ni. Okay, and then yang ini, this from negative to positive, so ini pula sama juga, direction of the loop is similar to the direction of EMF. Okay, so they are positive, right? Lepas tu kita tengok product of IR pula. If the direction of the loop is similar to the direction of the current, dia positive lah. Okay, so kita tengok R1 dulu. R1, direction of the current is similar to direction of the loop, so positive I1 R1. Okay, and then kita tengok R2 pula untuk resistor 2, sama juga, direction of the loop is similar to the direction of the current, so dia positive. Okay, sekarang kita tengok loop number 2 pula. So sekarang direction of the EMF is to the right, and then this one pula to the right juga. Okay, so kita tengok E2 sekarang ni sama direction. Okay, this loop is now clockwise. Sekarang dia ambil clockwise, so the direction of the loop is clockwise, and we see the EMF untuk E2 pula, epsilon 2 here, is similar to direction of the loop, so dia positive. Okay, and then kita tengok di sini pula, this one here, the epsilon 3 ni, EMF number 3 here, is going to the right, pointing to the right. Tapi direction of the loop there is pointing to the left. So because they are in opposite direction, it will be negative epsilon 3. Boleh? Negative EMF 3. Okay, now kita tengok product of IR pula. So untuk resistor number 2, the direction of the loop is similar to the current. Okay, so positive lah, positive. And then kita tengok pula untuk resistor number 3. Okay, so sekarang kita tengok current is going to the right, but the direction of the loop is going to the left, so dia akan jadi negative I3 R3. Okay, boleh. So kita dapat sudah equation untuk each loop. Now the last loop, this one is in anti-clockwise direction, so you should be able to do it because this is the same lah. Okay, so by solving equation 1 and any two of these equations from the closed loop, each current then can be determined. Okay, so from the calculation, if we get a negative value of current, it indicates that the direction of the actual current is actually opposite to the direction of the current drawn lah. So jangan risau kalau dapat negative. It's just telling you that the actual current is not flowing to the direction that we've drawn in the circuit lah. Okay, alright, so that is basically on Kirchhoff's rules, and this is very important because most of the students, some of the students have trouble solving this question. I hope you are able to understand from the examples and the exercises I've given lah. Okay.